If you're someone that drives, I'm sure you've experienced something like this on an almost daily basis. You're on your way to work, or school, or perhaps meeting up with some friends, but when you get there, the parking lot's completely full. You can't find a spot anywhere, and you end up circling around for 10 to 15 minutes, hoping that eventually you'll stumble upon a place to park. And by the time that you do finally find a spot, you're frustrated, you waste your time and money, and you contributed your fair share to climate change. Fortunately, we at Parkit came up with a solution. Parkmetriks, a real-time image-based parking availability detection system. The Parkmetriks system uses a network of cameras to extract live footage, which is then processed on board the camera with our expertly crafted image processing algorithm in order to extract parking availability detection information in real time. Then, all of the information is sent to the cloud where it is made available to the user via the Parkmetriks mobile application. The application then lets users search for parking nearby or at their destination, provide users with up-to-minute parking availability information, and navigates users using the Google Maps navigation system in order to guide drivers to their desired place of parking, providing updates on lot availability and even suggestions for better parking options along the way. The Parkmetriks hardware system is comprised of three main components which make up the entirety of the device. Looking at the following schematic, the central component of the Parkmetriks device is the Raspberry Pi 4 microcontroller, which has been selected because of its small size, low price, and a relatively powerful system on chip. The system includes a 64-bit quad-core processor with 2 GB of memory. It also has both Wi-Fi and Bluetooth support. Additionally, the Pi has 4 USB ports for connecting any peripherals, such as the Parkmetriks camera and an SD card slot. The second core component of the device is the high-definition camera capable of recording at 1080p at 60 frames per second. The camera also has a wide-angle lens to provide a 110-degree field of vision, which provides the Parkmetriks device the capability to detect more spots. Finally, the Parkmetriks device is powered by an iMuto X6S battery, which will provide the device with an entire day of power on a single charge. The first step of the image processing subsystem is the identification of parking stalls. This is accomplished by a series of transforms and filters that isolate the painted parking divisions. Then we analyze their orientations, and finally, we determine their center points. The algorithm determines the coordinates and identification numbers of the stalls and then passes them to the stall availability detection process. Using the tiny YOLO object detection algorithm for cars, we can identify the stall availability in parking lots. The tiny YOLO algorithm combined with the previously shown line detection algorithm allows us to identify exactly which stalls are occupied and which are not. We then store the process image information into multiple JSON files, which are subsequently sent to the cloud for further processing by our API. The Parkmetriks system uses Amazon Web Services to maintain and monitor the Parkit API. When JSON files are inserted into the Amazon S3 bucket, an AWS Lambda Python script is triggered, sending the data into the DynamoDB database tables. We need to be able to query this data. This is where the Parkit API comes into play. By programming more Amazon Lambda functions, we created HTTP GET requests that can query the data within the database. With the base URL, you can provide an ID to fetch the corresponding data. The mobile application's interface design is a crucial aspect of Parkmetriks. Being the main point of user contact, the entire user experience of our system falls on the shoulders of the front end. Users are able to search for parking nearby or at their destination in an easy manner. Upon selecting the parking lot of preference, they are greeted with up-to-date information about the entire lot. Similarly, users are able to tap and see more information about specific blocks of the parking lot. Users can select and be taken to any lot they wish using the search bar. However, if users prefer manually moving around the map, they can do so, as the Parkmetriks mobile application displays all the nearby parking lots using tappable markers. At Parkit, one of our top priorities is producing affordable solutions without the need to sacrifice performance. A great deal of time and effort has been put into finding hardware components that are capable of meeting our extremely high standards while also maintaining a cost-effective approach. The cost of the materials for the current Parkmetriks PoC is approximately $150. This includes the microcontroller, the rechargeable power source, and the camera. Even with our planned feature upgrades such as the integrated solar charging and custom built-in weatherproof enclosure, we will be able to keep production cost to approximately $400 a unit.